Okay, we're going to finish the graphing packet. These are all Common Core questions that have been asked in the last 3 Regents exams. And this is where they're going to give you some type of graph and they're asking you something about it. So question number 5 says the graph shows a line, which graph shows a line where each value of y is 3 more than half x. So my advice to you guys right here is to write this equation. Y is 3 more than half of x. So y is 3 more than half of x. There's your equation. All right, so if you take a look at this, well, my slope is 1/2 because it's in y equals mx plus b form, and my b is equal to 3. And now I'm going to take a look at my graphs, and I'm going to start out with, well, the y-intercept means we're dealing with a crossing of the y-axis at y equals 3. That's not choice 1, so we can throw it out. When we're dealing with a positive slope, okay, half x increased by 3, that's a positive slope. So I take a look at the remaining choices. Well, this is a positive slope. This is a positive slope. This is decreasing. That's a negative slope. You can throw that one out. All right. And then remember, a slope of 1/2, your y is in the top and your x is in the bottom. So you're looking for a movement of 2 in the x, a movement of 2 in the x, 1, 2, and a 1 in the y. And that doesn't make sense. Over here, a movement of 2 in the x and 1 in the y. 2 in the x and 1 in the y. It's going to be choice 2. Choice 2 is your best fit. All right, moving on. Question number 8 was the next question that we didn't take a look at. This was interesting. This is the first one I've seen in 9th grade where they broke up the graph into a couple of functions. So what we need to take a look at is we need to actually break it up into a couple of functions, the functions that we see. We're going to break it up right here. I'm not going to go through that circle because I'm going to explain what that little circle means. And we take a look at this, and this is the shape of a parabola. And when you have the shape of a parabola, you're talking about an x squared function. And when you take a look at your x values, it's going to be your x squared function, you know, going all the way back here and up to this certain point here. And that's what this says. If you read this carefully, f of x, this is going to be your y, remember, equals, well, we're going to have the graph of x squared when x is less than 1. So if this is 1, when x is less than 1, we're going to take on this x squared function. And if you notice, all of the functions that we see here are all going to have that same thing. When x is less than 1, we have x squared. So that whole first part is meaningless because every single one of the answers has that part. The other piece is this open circle. This open circle means that we cannot let x equal 1. And if you notice, this is x is less than 1, x is greater than 1, x is less than 1, x is greater than 1, less than 1, greater than 1, less than 1, greater than 1. None of these graphs have x equal to 1. All right, so that piece becomes meaningless with this question. So really, it's what this is going to be. Okay, and if you take a look at this line, we have to figure out, you know, what will be the equation of the linear piece. So if I take a look at this piece right here, it says x minus 2. That means my slope is 1 and my y-intercept is going to be a negative 2. If I were to take this line back to that graph right there, we would wind up with something that is not going to hit the x-axis at a negative 2, so we can get rid of this one. All right, same thing here. This is a 2x minus 7. The y-intercept is going to be a negative 7. If I take this graph back, I'm not going to get that. I'm not going to hit that y-axis at negative 7. I'm hitting the y-axis at a positive value, so I can get rid of this choice. All right. Again, I take a look at this y-intercept. The y-intercept is a negative 9/4. That's like negative 4.5. I'm hitting the y-axis there. Can't be this graph. So here's your answer. Okay, so that's a tough question. But you got to try to break it up into its smaller pieces so that we can. It really comes down to nothing more than looking at the line itself, kind of bringing that line back to the y-axis, and being able to determine the y-intercept. Question number 9. Right away we can get this down to a 50-50 because they're talking about the graph, this graph being the graph of y equals a x squared. And they're saying that if we multiply a by a negative 1/2, right, so first of all the graph opens upwards, which we know that for the graph to open upwards, a has got to be greater than 0, so that means a is positive. Okay? If we multiply that positive number by a negative 1/2, then a is going to become some value. We don't know what it is right now, but it's going to become less than 0 or negative, because a positive times a negative is a negative. So we're looking for a graph that opens downward, because that's what happens when, again, a is positive, the graph opens up, a is negative, the graph opens down. So we want a graph that opens downward. So far 1 is good. 2 we can get rid of, because 2 says it opens upwards. Narrow opens downwards. We're good so far. Opens upwards. All right. So we're done. All right. So now, what would the negative 1/2 be? All right. Well, let's take a look at the graph. Let's say we had the graph y equals 4x squared. All right. And we changed it because we multiplied a by a negative 1/2. Well, if we multiply a by a negative 1/2, we get negative 2x squared. And now watch what happens when I let x equal some numbers. Let's let x equal 2. Right? If we let x equal 2, on the original graph, we get 2 squared is 4 times 4. We get y is 16. So we go to 2 and we go all the way up to 16. So we're jumping. All right? Look what happens here. If we let x equal 2, we get 2 squared, which is 4, times a negative 2. We get a negative 8. So what happens is we're going to go x equals 2. We're going to come down. We're only going to come down to negative 8. All right? And then if we let x equal 4, let's say, 4 is going to be way up here. And what happens is when we go to 4, it's going to be someplace down here. So when you start taking a look at the graph and how it looks, you can see it's going to be wider. All right? So we're looking at a graph that's wider. The other way we can play around with that, guys, is you could look at and simulate this situation in your calculator. You go y equals, and again, we can go, I'll make it even easier. We'll go 2x squared. Actually, no, we'll keep it at 4x squared. So 4, and then hit x squared. And then I'm going to make a second graph in which I'm going to take the 4 and multiply it by a half. That's a negative 2x squared. Oops, sorry, x squared. All right, so we have those two graphs in. And if you take a look, hit window because you want to make sure you have 10 and minus 10, and we do, which is good. And we can just hit graph, and you can kind of see what's happening. There's the y equals 4x squared, and here is the y equals negative 2x squared. It looks wider, but if that doesn't show you, then you can play around with a different one, and let's just say, okay, let's make this 8. And then negative 1/2 of 8 will be a negative 4, and then we can graph that. And again, you can see now what you might have to do is you might have to pull this out a little bit and change your window. Let's say I wanted to graph this thing from negative 20 or negative 50 to 50, and y will be negative 50 to 50, and then we can graph this, and we can kind of see how thin that one is, and that one's thin too. It's hard to see in the graph, but what's going to happen is we go back to the original one, and we go zoom standard, and for the most part it's going to be a wider graph. When you reduce the a by a coefficient and you make it smaller, we're going from 4 to negative 2, it just spreads it spreads the graph out wider. So choice 1 is going to be your answer. All right, we go down to 10. And if we take a look at 10, 10 says a polynomial contains the factors x, x minus 2, and x plus 5. When we have a polynomial that has these as factors, remember that means we have this polynomial, whatever you want to call it. We can call it f of x if you want. And it has x as a factor, it has x minus 2 as a factor, and it has x plus 5 as a factor. So this is your polynomial right here. Now we could multiply them together and see what this thing looks like, or you can just remember that a polynomial is going to cross the x-axis at its roots, or a better word for roots is going to be at its zero. So we have zeros, we have roots, and we have solutions. So what we can do is we can just simply set this equal to 0, and we have three things multiplying to equal 0, which means the first has to equal 0, or the second has to equal 0, or the third has to equal 0. Well, you get x equals 0, and you get x equals 2, and you get x equals negative 5. So these are the places at which this polynomial is going to cross the x-axis. So I'm looking for a polynomial that's going to cross the x-axis at 0. Well, here's 0. This one's no good. I'm going to look for one that this one crosses at 0 and this one crosses at 0. I'm going to look for a polynomial that crosses at 2 and negative 5. All right, so 2, which is 0, and here's 2, and I'm going to go back to negative 5. This one is at 5, and that's a negative 2. So this one's no good, so it's choice 1 only. Question number 11 is a graph that we looked at before, but let's go through it again. They're showing you this graph, and they're asking you the Jameson family kept a log of the distance they traveled during a trip as represented in the graph below, during which intervals was their speed the greatest. And they said the first hour. Now, when we took a look at this before, remember, speed is going to be your distance you traveled, so distance traveled, divided by the time. So if we want to take a look at which one in which their speed is the greatest, all right, so we're going to take a look at in the first hour. Well, here's x equals 1, and here's x equals 2. All right, so you're looking at the x, which is the elapsed time, and so the time is going to be 1 hour, and the distance is going to be, well, they're at 40, and now they're at 110. So 110 minus 40, so that's going to be 70. So they traveled 70 miles in that 1 hour. Next, you're going to go into the second hour. Well, the second hour to the fourth hour. Well, the second hour to the fourth hour, they traveled about the same distance, but it took them twice as long to do that. So if we take a look in the second to the fourth hour, your change in your time is going to be 2 hours, but your change in your distance is going to still be 70 miles. 180 minus 110. So there's a speed of 35 miles per hour. All right, so far 1 is good, 2 is no good. We move on to the 6th to the 8th hour, from here to here. Well, again, the 6th to the 8th hour will come over here. That's going to be a change in 2 hours. And in that change of 2 hours, we're going to subtract these two numbers. 350 minus 230 is 120. And when we divide that, we get 60. Again, 70 was the distance, or the rate we traveled in the first hour. Now we're at 60 as an average speed in hours 6 through 8. So again, we're going to get rid of that because 70 is greater than 60. The 8th hour to the 10th hour. Well, here's the 8th hour to the 10th hour. And again, 8th hour to the 10th hour, we have 2 hours. And the distance they traveled was 40. 40 divided by 2 is 20. So when you take a look at that, you have speeds of 70 miles per hour, 35 miles per hour, 60 miles per hour, and 20 miles per hour. So the time interval for which they are traveling at the greatest speed, greatest average speed, is choice 1. And then number 12. Number 12, it says, which table of values represents a linear relationship? Whenever you're dealing with a linear relationship, your change as x changes, if this change is consistent, and you can see all your x values, negative 1, 0, 1, 1, negative 1, 0, 1, 2, 3, negative 1, 0, 1. If your x values are all consistently changing, like these x values are, they're all basically the same. A linear relationship means you're going to see the same change in your y values throughout. So for example, I'm going from a negative 3 to a negative 2. That's a change of negative 1. But then I go from negative 2 to 1. Now we're changing it now we're changing it by 3. You don't have to say just a change of 1, change of 3. This one has a change of 5, so no good. Negative 3 to negative 2, change of 2. Negative 3 to negative 1, change of 2. Negative 1 to 2, change of 2. 1 to 3, change of 2. 3 to 5, change of 2. This one is good. And again, you can take a look. Change of 1, change of 1, change of 7. Once that change changes, it's no longer linear. Change of a half, change of 1, change of 2, no good. Change in a linear function in your y's is consistent. That's what makes it linear. Choice 3. And that's it. There's a bunch of questions, Common Core, that deal with graphing.